right, boys and girls, what'd you think? You were probably going to get away from hearing my voice for the next several weeks, didn't you? Joke's on you. All right, so what you guys wrote down yesterday. You wrote down all the stuff that deals with the circle. So we have the center of the circle. The center of the circle is how we're going to name the circle, and we're going to get to that here in a second. You got a radius. Radius goes from the center of the circle to a point on the circle. And then you have this thing called a chord. A chord is inside the circle. It's a segment, and it goes from one part of the circle to another part of the circle. Now we have a special chord. That special chord is called the diameter. That brings us over to here. Whoa, there's a lot of stuff going on there, isn't there? Okay, so inside the circle and outside the circle, we got a couple different things going on. First, you have a tangent. A tangent's gonna hit the circle in exactly one spot. That spot that it's gonna hit the circle, that's called the point of tangency. Next, you got a secant that goes completely through the circle. Okay, goes completely through the circle, touches the circle in exactly two spots. Now, the tangent and the secant can be broken up into two smaller parts that we can actually measure. That's the secant segment, and that's a tangent segment. And those are going to come into play later on. We're going to get a couple theorems that are going to deal with those. All right, so the first theorem you got, theorem 10.1, talks about how when you draw a line, when you draw a radius is always perpendicular to a tangent. It can be a tangent segment, it can be a tangent line at the point of tangency. So that's going to be segment PB perpendicular to segment AC. And that happens every time. I could draw another radius up here, draw another tangent, and right where the tangent and the radius hit, that's going to be perpendicular as well. 10.2, on the other hand, this is your two tangent theorem. What's the two tangent theorem say? It says, I have a tangent. I have a point outside the circle. It's going to hit the circle in exactly one spot. That's why it's a tangent. It's a tangent segment. Now, because both come from the same point on the outside of the circle, here's point B, that AB, BC, they're both going to be congruent to each other. Okay? So that makes AB congruent to BC. So whenever we go into doing some of the problems that we're going to do from the packet, we would just set these two equal to each other, do your algebra, solve, you'll be good to go. Okay, we're back. All right, now we're going to do problems 12, 15, and 19 from the packet. Just trying to get you, get some problems in to show you how to do these, okay? All right, so for number 12, if you can see, we set it up. We have, again, our radius to our tangent, so we know it's going to be a right angle here, okay? So what I notice here is I've got a right triangle, and that's going to allow me to do the Pythagorean theorem. Now, maybe you catch something else going on here. Maybe you won't. We'll get into that here in a second. So I'm going to go Pythagorean theorem. So that's my leg squared plus leg squared equals hypotenuse squared. So we're going to write down x squared plus 96 squared equals 100 squared. Okay? And we're going to work through that. Or maybe, just maybe, if you remember your Pythagorean triples from back when, okay, we see that 96 and 100 can both be divided by 4. Well, if I divide both of those by 4, this is 25, this is 24. That means this is a 7, 24, 25 family. So for x, if I just take 7 times 4, x is going to equal 28, okay? Now, you could work through this with the Pythagorean theorem, or if you know your Pythagorean triples, x is going to equal 28, all right? That brings us now to number 15. So here's number 15. Now, I want you to pay close attention to what's going on here in 15, all right? I have leg squared. I forgot to put the right angle here. We'll put that there now. But notice your hypotenuse. Your hypotenuse is split into two parts. So I'm going to show you what's going to happen here when we do this. So we're going to do leg squared plus leg squared equals, now remember what our hypotenuse is. It's x plus 16, and that's going to be all squared. Okay, so this is x squared plus 32 times 32. That's, forget what that is. 32 times 32, 64, 1024. And that equals, so we have here, you're actually going to have to FOIL this. Remember, it's x plus 16 times x plus 16. So we're going to FOIL. We're going to say x squared plus 32x plus 256. Now you're looking at it and you're saying, okay, I got x squared plus 1024 equals x squared plus 32x plus 256. Mr. Boyer, what are you doing to me? Well, here's what we're doing. Looks crazy. Looks like it's going to be tough. But watch what happens. We're going to subtract x squared from both sides. The x squareds cancel. So now it's just a nice, regular old algebra problem. 1024 plus 32x equals, 32x plus 256. So now we'll subtract 256 from both sides, right? And so I have an 8, I have a 6, I have a 7, that equals 32x. So now we're going to divide both sides by 32. And what's x going to equal here? We divide both by 32. 32 goes into 76, goes twice. I get 128. X is 24. Okay? That brings us over now to the two-tangent theorem. If you remember what we talked about with the two-tangent theorem a little bit earlier, we're going to set these equal to each other. So JK and JM here are equal. So this is going to be 3x squared minus 10 equals 17. Add 10 to both sides. 3x squared equals 27. Now we divide both sides by 3. X squared equals 9. Okay? Now, remember, this 2 here, that tells me there's 2 answers. Maybe they both work, maybe they don't. But what number times itself equals 9? There's 2 answers. That's going to be plus or minus 3. Okay? Now, put both of those back in there, and you'll see they actually both work. Okay? They actually both work. So those are the 3 problems that we're going to go over. There was one thing I forgot to mention, how to name a circle. If you revert back to the beginning of this video, you'll see that we just name a circle by taking the center of the circle, drawing a circle with a little dot in it. That's going to be the symbol for circle. C. That's it. Same thing here. Circle C. This one, circle L. Okay? So what I need you guys to do, page 184, 185 in your packet, 5 through 20. Now I did 3 of those problems. You're welcome. You can thank me later when we get back to school, eventually, hopefully. Okay? So you're going to do 5 through 20 to rest. When you're finished, you need to take a picture, do something, send it to me on Schoology. I'll be able to mark you down. Okay? So every day, we're going to leave you with either a quote, a rap. Yeah, that's right. I said rap. I can do that. Or just like something like today, it's just going to be save a life, wash your hands. Have a good one.